Serge, thanks. That's correct. I think a lot of you people over here know that. We have to go to the right now. A lot of you people know that a lot of time dedicated in CAE goes into geometry, actually. There's a whole process, but we still have to discretize. And a lot of discretization helps, starts at the beginning of your engineering process. I've seen a lot of engineering processes. Thank you guys for using the software and giving you insight into your processes, but you still have to pre-process. You have to discretize. So how can you do that with MSC Apex? We have a lot of pre-processors in our portfolio. Apex is one of them, and what is the distinction with Apex? It's really going to turbocharge the process. Where does Apex reside in the horizon of D&E? And that's basically in structures. But Koen already presented something about Adams Modeler. Adams Modeler is also in Apex and helping you with turbocharging your process. So this is the schedule. I'm going to speed up because all my colleagues know I can talk until 8 o'clock, but then you don't have the drinks and you don't have the nice food that is going to be there. So I'm going to speed up. Just remember this. Build up. And one of the most typical things, this is a proof of concept actually that we did with a customer, and you're going to see some more details on the next slide, is that we've compared it with our preprocessor Patron, with a competitor piece of software and Adams, and in 3D and in 2D we both see significant reductions in time for preparing your CAE. It's up to 95% for 3D, up to 70% for 2D, and let me give you some extra details on the proof of concept. For my previous aerospace colleagues, you see in the bottom right, it's Spirit, where we did the proof of concept with, and what they did was a comparison between Patron, native software they have inside. I don't know the details of what they're using, and they didn't want to disclose. And they compared it with Apex. And what you see is that they typically did some examples on 2D. I think it was a piece of a wing where they wanted to do mid-surfacing and preparing geometry. And they did a 3D example. And in both cases, there was a humongous decrease in time that they needed to pre-process the geometry. Okay, what can you do at that time? You know, typically when you're in a process, you receive your geometry, you have to clean it up, mesh it, have your loads, have your boundary conditions, do some debugging, look at your mesh quality, and then solve it and post-process it. So after that, you have your first insight. You're like, okay, this looks good. I have some red spots, that's management plots. But then you do your first iteration to get rid of that red spot. You do an iteration, you get more insight. You do your second iteration, but then usually you're already approaching the time that you need to certify, or at least have to hand in your report to your manager. He's like, okay, you have to get rid of that red spot in my piece of structure, and I want to report because my client is asking again. We saw a 95% reduction in time for 3D, about 70% 2D. So let's take it conservatively and say that you can reduce the time by 2. Then your report still has some room, you know, before you have to hand in your report. You already have your first iteration, your second iteration, but what can you do with that extra time that you get by using Apex for your geometry? You can iterate again, and iterate again. What you can do is at least get more insight and maybe do innovate. The other thing you can do with that time is resources, you know, we're stretching resources. I think everybody in this room is looking for somebody, and you know, it's difficult to find people. So what you can do actually with that gained time that Apex is giving you is you can do one project, but the same kind of resources in the other piece of time they have can do another project. So how is Apex helping you in that? It's a game-changing user experience. It's really, some people say when they look at it, is this a cut tool? No, it's not a cut tool. It's a cut tool resembling something you can do in CAE, or it's a CAE tool for cut engineers. It's that flexible. It's very powerful. It has a strong set of geometry modification sets like defeaturing. It's helping you mesh. It's helping you defeature. It's helping you mid-surface. It's very open and it's very customizable and automizable, if that's a correct English word. It's directly linking with Python. So geometry cleanup. I know from my experience as an aerospace engineer that I could spend quite some time in cleaning up the geometry. And that's not because my design engineer would give me a crappy piece of structure to work with. It's just that the two languages in CAD and CAE don't really talk very good to each other. So what are typical pains? Usually CAD, coming from any package, is not directly suitable for meshing. You really need to clean it up. And a significant amount of time is spent modifying that geometry to fit it for meshing. So the Parasolid engine below Apex is that powerful that it can find errors in the solid for you and fix it automatically for you. You don't have to do that automatically. Obviously, you can also check per error if it's really an error. You can address corrupt and damaged geometry. It can optimize the geometry for you, and that means that it optimizes the geometry so it can be meshed for you within Apex. And well, defeaturing is almost natural. Surface meshing, I know a lot of our customers still do 2D meshing. There is very powerful, well, actually very powerful tools, several tools, about 5 or 6 tools to do mid-surfacing. Totally linked to your geometry, so when you have a mid-surface, you can map your thickness of the solid onto your 2D mesh, and it's there instantly. Solid meshing. I know a lot of people or a lot of engineers do solid meshing, and my solution usually was, okay, it's too difficult to hex mesh, I have a solid, let's put tetrahedral elements in it because that's easy. But then still, you need to clean your geometry. Usually you have features in there requiring defeaturing because even a tetra mesh is not really filling your solid as you expect or giving you actually element quality that you cannot use. So again, Apex with the geometry engine behind that can help you with that. It can partition the solid into partitions that are easily tetrameshable. Okay, it's still tetramesh, but okay. You can use surface mesh as a seeding for your three-dimensional mesh. But the next step is, and I moved away from hex meshing because it just took me too much time. I just put in tetramesh and solved my problem with that. But with Apex, hex meshing is coming into play again. It has a button that you can turn on, and it color codes your solid. It basically says red, okay, it's step mesh, you can still mesh it. Yellow, it's a combination. But green, you have a hex meshable. And it can help you in getting that, for instance, in this case, the strut, to become fully green. And fully green means that you can hex mesh it. How does it do that? It does that with the split tool. The split tool is something that you can use to split the solid into several solids, but you can use the split tool to split your solid into several partitions that are hex meshable after you have split them. Apex determines that automatically for you, and you see the color changing of your part as you go. Starting from a mesh, Apex, because of the very powerful geometry engine behind it, you can import a legacy BDF. So you don't have any cut available, you have a mesh available, you can import it into Apex and recreate your geometry from that. A huge problem usually with importing a BDF is that you use the loads and the boundary conditions. They stay when you import them in Apex. They stay when you recreate the geometry. You can even apply the loads and boundary conditions when you have recreated the geometry back onto that geometry and make it dependent on the geometry. So when you change the geometry, then your loads and boundary conditions still remain. It converts first into facets. I think that was the first option we had in Apex. It's actually easy because if you receive something, it just takes the facet of the mesh model and makes geometrical facets of that. But it can fully recreate power-solid geometry that you can then again even export to your CAD tool and give to your design department if you have a separate design department. So the key takeaways of Apex, there's more, and I'm very open after this session to show you some extra stuff of Apex. Key takeaway is that it's a very efficient geometry tool. It will give you sufficient and productivity gains that I couldn't even imagine. For me, within In Summa, it's my go-to tool for geometry. I work with Mentat, I work with Mastran, I work with other tools within the huge portfolio of Hexagon. But currently, my CAD tool for geometry modification and meshing is Apex. It's so intuitive, it's easy to use, it's easy to learn. It has a built-in learning tool. Obviously, we can give you a course, we can teach you a course, but if you want to teach it yourself, it's built in. And both senior and less experienced engineers benefit from the intuitivity of the tool. So, that brings me to the end of my presentations, and I think also at the end of today. Matthijs will do a wrap-up, but I would really like to ask to do not forget the feedback. Please be kind to me. I know I'm the last one. Leave your feedback. You can tear it off your leaflet and hand it in, so we can give you after this one an even better conference than we had already. Thanks a lot, guys.